Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib with my co-host, JP.
Hi, how are you?
And we are excited to have a special guest today, Dr. Barb Woerger. This episode of the Health Upgrade Podcast is brought to you by Woegerer. Have you been looking for a simple way to feel calmer, think clearer, and sleep better? Imagine achieving this with just 2 minutes a day. I'm excited to introduce you to Woegerer, a handheld device that supports your nervous system through gentle vagus nerve stimulation. As a doctor specializing in functional health and wellness, I've seen firsthand how Woegerer has accelerated healing in my clients. I've used this device to help people with a range of issues, from sleep disturbances and heart palpitations to digestive dysfunction, nervous system imbalances, and mental wellness concerns. The results have honestly been remarkable. Woegerer is designed to catalyze and accelerate the shift in your body from fight or flight to rest, digest, and recover mode, helping you manage stress, maintain mental clarity, and unwind more easily. It's not just theory. I've witnessed its positive impact on real people facing real health challenges. The best part? Woegerer fits seamlessly into your routine. No need to carve out hours for wellness. Just 2 minutes a day can make a difference. It's a small investment of time for potentially significant benefits in how you feel and function each day. If you're curious to experience Woegerer for yourself, visit woegerer.com/upgrade. You can save $30 on your device by using the code UPGRADE30 at checkout. Remember, that's Woegerer.com, TRUVAGA.com/upgrade. It might just be the first step towards a calmer, clearer you, just as it has been for many of my clients. How are you, Barb?
I am very well. Thank you so much for having me on this show. I am so grateful to be here.
We are honored and excited to talk to you. I'm especially excited. We met years ago at a local event because you are local to me here in Toronto. But we met, and I don't think at the time we either had a niche, really. Like, I had started talking about vagus nerve stuff, and you had started talking about magnesium. And now, 5 years after we first met, we've both gotten deep into this niche. And we're really excited to kind of understand the story, your journey into naturopathic medicine, what kind of brought you into there first, and then understand the role of magnesium and how you use it in practice. So give us the rundown. How did you initially get into naturopathy?
Yeah, I actually didn't get in how most people would with a health issue or anything like that. But my previous life, or I'm sure, a career was in life insurance and disability. And so I was always asking people these medical questions, and the amount of people that had diabetes and heart issues and cancer diagnoses, it was just unreal. And I had always had a passion for health, and I had done my holistic nutrition certification at that time, and I wanted to get deeper into that. And so I went back to university and kind of got my pre-qualifying credits that I needed for going into naturopathic medicine, because I had looked at that and wanted to proceed with that. So went back to university for 4 years, got the proper degree, got all the credits that we needed. And then I applied to the Canadian College of Naturopathic Medicine here in Toronto and did a full 4 years there, plus 1 year of internship. So it was a rigorous program, and we learned lots of things. But one thing we didn't learn a lot of was about magnesium. And how I actually got into magnesium was once I got into practice. In Ontario, we have OHIP, which is an Ontario Health Insurance Plan. And so we tend to get patients come in when they haven't been able to get the help that they have needed from the conventional medical system or their doctors. And so my first few patients were like all patients that, you know what, we can't do anything else. Is there something that you can help me with? And every time I went down into the research, I would get into this mineral magnesium and be like, oh, make sure that magnesium is optimal, or it's this pathway that gets activated. It's this enzyme that needs to be activated. And so I was doing my N of 1 studies and sending them literally home with the only thing, magnesium supplementation. And they were calling me back in a week going, oh my goodness, I feel better. I've had an improvement. This has improved. And so I just started keeping track of it. And a few years into my practice, I was getting a long list of things. And it was at that time I really started to dig deeper into the research and how much this mineral does for us. And yet we don't talk about it a lot. It's not given a lot of attention. They throw basically sleep and stress, and there's your benefits of magnesium. And that's pretty much all we learned about it in school. And so it's a really eye-opening mineral. And I'm so grateful that I was able to dig deep and to go down that pathway. And I'm happy to share all that I know about it. Yeah.
I love it. What would you say? I think this might answer a lot of questions, but I really want to get down to understanding what is the role of magnesium in creating optimal health? Because a lot of people, obviously we're suffering from health conditions across the board, right? Chronic diseases are often linked to a deficiency in magnesium. But what are some of those cellular processes that magnesium is required for in order to ensure that we are able to function at an optimal cellular physiological level?
Yeah, well, we would be here all day if we talked about every single one. But so one of the things that is really important to, I guess, first of all, understand about magnesium is that as of the latest research that was published in December of 2023, they have been able to determine that it is responsible for 800 enzymatic reactions. So in plain English, it's involved in a lot of enzymes and coenzymes and pathways that need to be activated by certain minerals, magnesium being one of them. So this is going to affect, with so many enzymatic reactions, it's going to affect literally every system in the body. So whether it's our DNA, whether it's our RNA, whether it's our immune system, whether it's our nervous system, our heart, our kidneys, it literally touches on every system. And this is why it's so important for optimal health, because a lot of the deficiencies that magnesium shows are actually like symptoms of many other illnesses or many other health conditions. And so it's really hard to distinguish. And nobody ever thinks about looking at magnesium as an option because they are part of so many different health conditions. So its role is huge when it comes to our health. And like I said, we could be here all day talking about all the different systems and all the different pathways that activates. If we just chose one simple one, like vitamin D, we're also very deficient in vitamin D. It's no coincidence that there's a deficiency in magnesium and a deficiency in vitamin D. It's because those two need to be together in order for vitamin D to be activated. Magnesium needs to do the enzyme process in the kidney and the liver in order for us to get vitamin D to work in our body and do the things that it does. And I think when we look at it from that perspective, they're not coincidences anymore. It's actually how processes work. And this is the important part of why I think I've taken on this role of wanting to get as much information out there about magnesium.
Let's talk about, because we always talk about the nervous system, and we occasionally talk about mitochondria, and we talk about the immune system. Let's tackle any one of those three that you think would be the most interesting to start with. I always think of the nervous system as sort of the one that coordinates everything. So maybe we can hold off on that unless you'd like to. Maybe in line with the cellular processes we were just talking about, maybe start with mitochondria. How does magnesium impact our ability to properly generate ATP?
Yeah, so great question. And we know that ATP is kind of like our energy currency in the body and that it powers just about everything in our cells. And so magnesium is going to be really essential here because it's going to help to synthesize and stabilize that ATP. So without magnesium, ATP actually can't be properly stabilized or made in the cell. And so that's really crucial because for those tissues, they need a lot of energy, like brain or heart or muscles. And those organs are going to depend on that constant, reliable energy that magnesium is going to give. And so it becomes a really crucial factor. It also plays a role in keeping our mitochondrial stable by what's called the mitochondrial membrane potential. Now it's going to be more scientific, but that potential is essentially an electrical gradient that crosses the mitochondrial membrane that drives that ATP production. And so magnesium is going to manage calcium entry into the mitochondria, and it's going to prevent too much calcium from building up because too much calcium is going to throw off that membrane potential. And then, of course, it's going to disrupt the ATP production. And then that's going to lead to cell death through a process called apoptosis. So it's particularly important for the neurons and muscle cells when there's that overload of calcium. And so magnesium is going to make sure it keeps calcium in check. And that's going to keep our mitochondria healthy. And it's going to also support like long-term cellular resilience as well. And then finally, we probably have to look at also is that magnesium plays a role in managing oxidative stress within that mitochondria. So as a natural byproduct of ATP production, we get this thing called reactive oxygen species. And we get a little of it is normal. We all have it. But when that becomes too much, that's going to lead to that oxidative damage in the mitochondria. And that's going to hurt the DNA, the proteins, and the fats that are inside these mitochondria. So magnesium is going to kind of step in and support the antioxidant defenses like superoxide dismutase or SOD. And it's going to neutralize those reactive oxygen species. And that protection is important, especially in mitochondria, because they, as I said, they're our main energy currency. They're going to create that ATP. So those are probably the big things that magnesium does within the mitochondria. And we know how important the mitochondria are in so many different pathways in our health, whether it's our heart, whether it's in our nervous system, right? Like we have all this oxidative stress and our mitochondria are being affected by it.
Within the mitochondria, as you mentioned, the calcium is a very important player. And maintaining the right level of calcium, the mitochondria actually act as a calcium buffer in the cell. One of the things that we talk about a lot is a receptor called the alpha-7 nicotinic acetylcholine receptor, which is an ionotropic calcium channel. And it's activated by acetylcholine released by the parasympathetic nervous system, by the vagus nerve, and also by elements of the immune system. But I'm wondering whether or not there's a parallel here or maybe an overlap of magnesium's role and calcium's role and the vagus nerve. So as we sort of continue through this conversation, it'd be sort of maybe we'll come back to it a few times, talk about how the vagus nerve and the release of acetylcholine and this modulation of calcium through this receptor, how that plays a role in magnesium, or how magnesium plays a role in that proper function. Because it sounds to me like several of the things you were talking about there, both ATP synthesis, maintaining that gradient, preventing reactive oxygen species. For example, you mentioned superoxide dismutase. What about glutathione and melatonin? Maybe not so much melatonin, but glutathione. How does magnesium play a role with glutathione?
Well, magnesium is required in order to make glutathione, right? It's one of those enzymatic reactions that we were speaking about earlier. And the same with melatonin. We need magnesium in order to make melatonin. A lot of these reactions are happening by enzymes that are coming in throughout a pathway and that are creating that. And this is where this 800 enzymatic reactions are coming from. So this is actually just starting to get picked up in the research much more. Like when I first started looking at magnesium and the different pathways, they were at 300 enzymatic reactions. And that was like back in 2000 and maybe 18, 19, maybe even earlier 17. So you can see how far they're coming. And we have so much research coming out now on all of these different pathways. And so, yes, it's going to affect glutathione. It's going to affect melatonin. It has, especially the calcium regulation piece is big with magnesium because it counterbalances. And like you had said, it does have a role in the nervous system as well, because calcium's excitatory effects in nerve cells, they are going to be, that's how magnesium kind of controls that nervous system. It's controlling the amount of calcium that's coming into the cell. And when we know that when calcium enters neurons in an excessive fashion, it's going to lead to that overstimulation. And so magnesium is going to modulate that process and ensure that that nerve activity kind of remains steady and controlled and not overstimulated.
It sounds a lot like the role of magnesium throughout all of these different cellular processes is to be a regulator, is to be a stabilizer, right? It's a counterbalance to a lot of these functions that are required for our optimal kind of functioning. But if there's a lack of regulation or a lack of control, it can become a process that it kind of goes off the deep end. And one of those processes that I would love to kind of dig into with you is the process of inflammation, because inflammation is a necessary process within the body. In acute situations, inflammation is required for us to function well. I'd love to know the role of magnesium in ensuring that we remain in an acute inflammatory reaction and not allow that reaction to become chronic, uncontrolled, long-term inflammation.
Right. And so that's going to go back to basically what is causing that inflammation, right? So we have the reactive oxygen species. We have certain proteins that will cause inflammation. We have inflammatory pathways. And so what we look at when magnesium is anti-inflammatory, so there's lots of research on that, it's because it's actually reducing some of that oxidative stress. It's reducing, cortisol levels. It's reducing the things that are actually causing inflammation. So, if we look at all of insulin or cortisol or the neurotransmitters that are overabundant, they can sometimes cause some of these inflammatory reactions. And what magnesium is doing is just like you had mentioned earlier, it's a controller, it's a regulator of other pathways to reduce. So it's like it's indirectly targeting certain things in order for it to do its job. And so as an enzyme or a coenzyme or a regulator or whatever we want to call it, it's actually going into the background and taking care of some of the things that are actually causing those inflammatory processes to happen. And so it can, activate it can help in activating that vagus nerve in order to, even if we have nervous system dysfunction, we are creating an inflammatory process. Anytime the immune system is activated, there's an inflammatory process that's happening, and it's magnesium that's coming in and doing the behind the scenes work that is causing the outcome is then lower levels of inflammation. So it's not a direct something like, for instance, curcumin that's actually going down a direct pathway and taking care of that inflammation. It's doing this work in the many processes in the background that is actually causing many of the inflammatory issues that we see.
And that would explain why depletion of magnesium, which we see so broadly, is so heavily linked to many of these chronic health conditions or chronic inflammatory processes, right? If we don't have that back-end regulatory mechanism, that mineral that's required to help to lower the root causes, and I love that you brought up the fact that we're addressing the root causes with magnesium. That's really what the missing role is when we're depleted. Let's talk a little bit about this, because we do know that magnesium deficiency is pretty widespread throughout our entire population, whether we're in North America or wherever. Let's talk a little bit about magnesium deficiency and how we kind of identify when people are deficient. What are some of the symptoms? What are some of the more common challenges that you see in practice?
Yeah, so magnesium deficiency it's wide range. And I think I want to just back up a little bit. And a lot of people will come into practice and they'll be like, I have my magnesium tested and it's fine. I'm fine. And I'm like, okay. So the one thing we have to understand before we actually go into the deficiency is The serum magnesium that they're testing on blood work, on your regular panel yearly, is 1% of the magnesium in your body. So it's really not a reliable measure. And so the RBC magnesium, which is the next step up, which is the red blood cell magnesium, still not a great test, but will tell us a little bit more than just the serum magnesium. But in the research, what they've actually found is that there's really no great test for deficiency, because they took people that had proper levels or normal levels or even high normal levels of serum and RBC magnesium, and they did tissue and muscle biopsies, and they were still deficient. Now, this is because 60% plus of your magnesium is in your tissues and your bones. So very hard to actually test unless we're doing more invasive testing, such as, muscle or tissue biopsy. So this is why we know that 60 to 70% of the population is likely deficient in this mineral. Now, some of the deficiency symptoms, as I said, are going to be very key to other health issues. So we could have insomnia, have that increased stress. We can have sleep disorders, mood disorders, joint pain. We can have muscle aches. We can have tension, anxiety. There's so many little things that are going to, even digestive complaints, acid reflux. Like, these are all symptoms that are of another health condition. And so they're often overlooked, and they're not treated with magnesium first to see if they actually correct themselves. They're treated as part of whatever other health condition that they belong to. But in the book, I believe we had like 60 different symptoms. So there's a lot, and they're going to be very small, some of the people, and some of them are going to be very big. But there's a lot more than just stress and sleep.
One of the things that I noted when I looked at that and when I hear that list is the overlap between that list and what you see with chronic sympathetic overdrive. When people are in a chronic stressed or chronically inflamed state, they're going to experience a lot of those same symptoms. And it sounds to me like an interesting test might simply be an autonomic nervous system test. And if you find that the person has very low heart rate variability, very low parasympathetic tone, very high sympathetic tone, that could be a cue that the person is deficient in magnesium. Now, which came first, the chicken or the egg, whether or not it's, I would assume that the draw or the depletion of magnesium in the system is a function of how much it's needing to be used. Although you can't, I'm trying to figure out what would cause a depletion other than simply electrolyte loss from sweating and running and doing things like that. What could be a driver of deficient or loss of magnesium in the system? Do some people just simply metabolize it out of their bodies more quickly? How does that work?
Yeah, so there's a lot of ways that we deplete magnesium. So magnesium is depleted, as you said, through diuretic loss. So whether it's sweating or diarrhea or something like that, you're going to lose your electrolytes. That's one way. Obviously, we're not getting as much in the diet anymore. Sugar is burning through our magnesium stores. So there's it's a biochemical reaction because it has to take. So in the research, it states that when they looked at one molecule of sugar, it took approximately, and there was a variation, 30 to 54 molecules of magnesium to process that one molecule of sugar through this biochemical reaction. So we know that sugar and processed foods are going to deplete our magnesium stores. We also know that certain foods, so some people have lectin deficiency. Some people have legumes that they can't. So if they're eating those foods, it's actually depleting our magnesium. Fluoride competes with magnesium. So we have fluoride in our toothpaste and in our water. And so that's depleting magnesium. Stress depletes magnesium. It helps with our stress. But if you're also super stressed, we're depleting our magnesium. 1 out of every 3 people are insulin resistant right now. And insulin resistance actually depletes our magnesium because we're losing magnesium through the kidney, through urine. And so we are losing it that way. Medications, diuretics, proton pump inhibitors, antibiotics, chemotherapy drugs, these are all depleting our magnesium stores. So there's so many different ways that a person can actually lose magnesium from their system. And if they're not repleting or bringing in enough magnesium, they're going to be in this deficiency state. And, the RDA is based upon a weight and a sex, and they've kind of come up with this number, but they also know that those need to be updated. And our RDA for magnesium hasn't been updated since 1997, and weight has gone up. And so in a research study, they were looking at what it would be in 2021, and they were already 200 milligrams higher than the RDA is today. And so if we're not bringing in what we're taking out or what we're depleting, we're going to be in a deficiency state. I mean, stress is rampant, as we know, in the society. And if we're not doing something to lower that stress, our body is just blowing through that magnesium stores.
Yeah, one of the things I try to tell people is that the world isn't going to get any less stressful, but we need to become more resilient to it. We need to become better handlers of stress. And it sounds to me like depletion of magnesium, which, as you sort of hinted at, there's a depletion of magnesium along with many other minerals and nutrients from our foods. It's a big movement down here in the States, this idea that looking at our food manufacturers and inspecting what it is that they're putting into our foods, and more importantly, taking out of our foods, is really important. And magnesium, I suspect, is one of those things that if you look at foods that were grown 50, 100 years ago, they were much higher levels of magnesium in those foods than you have today. So supplementation is really important. I think that's a really great segue into what are the best ways to take magnesium, because there are many different supplement forms. There's both in terms of powders, creams, pills, oils, etc., but also what the chemical composition of those things are. Can we talk a little bit about, maybe decode some of that for people?
Yeah, so there's many different magnesium forms, as you mentioned, and there's also different routes on how we can get our magnesium in. So we can have Epsom salts, which are kind of bath salts or chloride flakes. There's the oils, the creams, the gels. Then we have the actual supplementation, which can come in a powder, a gummy now, a liquid, and a actual capsule. And so what we want to do first off is to make sure that whatever route we're doing or whatever we're taking is at least the best that we can get as far as purity. So unfortunately, with a lot of the gummies and a lot of the liquids and the powders, they're adding flavors in, they're adding different things in, and that's going to disrupt the magnesium composition, right? So I just said sugar is going to deplete magnesium. So if we've got a lot of flavors and sugars coming in, I know they want to make it taste palatable for people, but we're kind of defeating the purpose if we're starting to get too much of the stuff coming in with other like other things attached to it. So a capsule is usually the best route, because we're usually just getting the glycine and the magnesium, or the citrate, the citric acid and the magnesium, depending upon what form we're looking at. But there are clean powders out there. There are clean liquids. So it's just making sure we read the labels and ensure that we're getting the best possible form into us. Now, there's going to be different forms. As I mentioned, there's like 17 different forms, but the ones that are most available in most health food stores or on shelves, there's usually about 5 or 6 different forms. And so what I have found in practice, and what I've also seen in the research, is that if we want to treat one specific or a major specific symptom, health issue, health condition, using a particular form, usually one form, maybe 2, is going to provide a better outcome than trying to take a magnesium combination where there's maybe 5 or 6 different forms of magnesium. And that's just simply because we can't get to therapeutic levels, because we don't actually know what each of those different forms of magnesium in that combo are actually, like what the value of those are. And that can sometimes be a little bit difficult for people to figure out. And then, of course, we have to be careful that we're not overdosing. So that's another issue there. So I like to go with usually 1 or 2 different forms and then dose them therapeutically to whatever that condition is that we're dosing for. But if we're looking at different forms, then we have probably our most popular and the most common that people hear is glycinate or bisglycinate. And this is a glycine molecule, 2 glycine molecules that are attached to magnesium. And what's important to understand is that magnesium alone is really hard to get into the cell. So these are kind of additional amino acids that we add on that actually help it get into the cell better. And with glycinate and bisglycinate, they're the same thing. We know that the absorbability is really high. The bioavailability is good. It's well tolerated. It's not hard on the stomach. It doesn't usually cause any digestive upset. And it's great for anything to do with the nervous system. I like to use it. It's like an all-around form. It kind of touches on a lot of different things, but its biggest aspects are going to be in that nervous system, relaxation, sleep. It's good for joint pain, just relaxing the entire body and calming down that entire nervous system. And I use it very frequently, and we can dose it so that it's therapeutic to whatever you want to address. From there, we have citrate, which is another pretty popular magnesium form. Now, it's more for digestive function, so it's more for constipation. I use it for acid reflux. We can use it for sleep, although it does have some GI issues with people. Yeah, like if we dose it too high, some people will end up with diarrhea or loose bowel movements. And so you have to be kind of careful, and you have to kind of titrate with that form of magnesium. And it also has a little bit more digestive upset because of the citric acid. But otherwise, we use it for prevention of migraines as well. There's lots of good research for that. And that is available in powder, usually in gummy and in a capsule form.
How does magnesium citrate draw or create that gut function? Is it more of like an osmotic effect to bring,
Yeah, it pulls the water into the bowel, and that's how it helps with the constipation. It brings more water into the colon, and it allows for easier bowel movements and less straining because it's moving things along. So yeah, it's considered an osmotic laxative in the constipation world. Yeah. But magnesium bisglycinate can do that. It's just at a much lower level. So this is what I was saying with if we take multiple different forms, we can't get the same dosage in a therapeutic range to actually do what we want it to do. So usually doing just single forms of magnesium is the best. Yeah.
Let me just ask this because I don't know, but what you sort of described was in situations where there's a therapeutic or a medical problem that you're trying to address, then specific forms are superior. So you mentioned earlier that you like to prescribe a specific type of magnesium for a given medical problem. But for people who don't have a medical problem and want just a general increase in magnesium, it seems like maybe having a broad spectrum of different types of magnesium would be best. Would that be correct?
Yes. If they have no medical issues, no health issues, and they just kind of want to take magnesium to kind of make sure their stores are adequate, then a combination product that has maybe 4 different forms of magnesium is fine. The only thing I would caution is making sure you look at what the forms are in that combination product. So what I'm gearing to is you want to make sure that your product doesn't contain oxide, or if it does, that you can actually figure out how much oxide is in that combination. So one of the things that manufacturers like to do sometimes is add oxide in because it is a very inexpensive molecule. The only problem is we can't absorb oxide. Less than 5% is the absorption rate of oxide. It works as a wonderful laxative if we need it, but it has no other benefit to us besides that. So if you're going to take a magnesium product, you're going to want to make sure you're getting some benefit. You don't want 400 out of your 500 milligrams that you're taking to be oxide. So you either have to contact the manufacturer or go on their website and see if they have a breakdown, or just get a supplement that doesn't have oxide in it.
Is that milk of magnesia? Is that what milk of magnesia is? It's the magnesium oxide?
No, milk of magnesia is hydroxide. So yeah, but it's very similar. We can absorb it. It works as a laxative, and it's best use for it. Yeah.
When I'm working with patients that have had either brain injury or noticeable cognitive decline, issues with brain health overall, there's one particular form that I like going to, which is magnesium threonate. And that's particularly because I believe it crosses the blood-brain barrier, and we have improvements noted on the cognitive side of things. Talk a little bit about threonate, because I think that's a really powerful tool when it comes to brain health.
Yeah, so magnesium threonate is kind of the new player on the block. And we're getting more and more research coming out on it. And it's basically a magnesium salt of the L-threonic acid that's derived from vitamin C. And so, as you mentioned, it crosses the blood-brain barrier. It has really good bioavailability, and it makes it really effective for targeting brain magnesium levels. So it's going to, some of the key benefits of that form of magnesium is going to be memory improvement, cognition function. It supports learning, concentration. A lot of the research is on cognitive decline patients, dementia patients, and they're looking at cognitive function after taking magnesium L-threonate. And what they have noticed is that it improves their brain age anywhere from 6 to 9 years with 12 weeks of dosing magnesium L-threonate. So that is where a lot of the research is coming out. But we also know it helps reduce neuroinflammation, right? So it has those neuroprotective effects, reduces oxidative stress, and it prevents kind of that neuronal loss. It's very good at helping neuronal connections in the brain, which is very helpful when we're looking at dementia and cognitive decline. But we're now seeing more and more research coming out on the mood part and the stress management part, and how it's regulating neurotransmitters like serotonin and GABA and promoting like emotional balance, which then of course will also play into sleep quality and, nervous system function. So it has a wide range, and we're learning more and more about this form of magnesium as we get more research. I mean, they're looking at also concussion patients and post-concussion patients and traumatic brain injuries and those kinds of things with this form of magnesium as well. So yeah, if we want to understand how it works from a very simple perspective, and this is what most of the research is telling us, is that it's going to enhance the function of the NMDA receptors, which are involved in that synaptic signaling. And so this is what's causing the increase in plasticity in the hippocampus. And then that's obviously our brain's primary memory center. And this is where we're getting a lot of the information on these cognitive decline patients when they're using this supplement. So it's very much for cognition and memory and just preserving brain health.
A lot of what you're describing, again, we've talked about on this podcast multiple times, talking about the role of microglial cells and the brain's tissue-resident macrophages and how they impact all of the things that you're talking about. So again, I'm coming back to this idea that inflammation in the central nervous system and how we can downregulate the activation or inflammatory activation. Because I don't want to suggest that microglial cells shouldn't be active, because they should be. They should be active in a homeostatic state, doing all the monitoring and maintaining and supporting of brain health and brain growth. But everything from serotonin synthesis and melatonin synthesis to the levels of MDMA receptors, GABA receptors, et cetera, all of that is regulated by the levels of inflammation, which are controlled by microglial cells, and the synaptic connections, synaptogenesis and synaptic pruning, even neurogenesis and the migration of neurons into the proper position in the network. All of that is coordinated through microglial cells, and I'm wondering whether or not one of the cardinal signs, if you will, of magnesium depletion is a bias towards microglial activation. Do you see higher levels of inflammation simply because of a lack of magnesium? And when you supplement, do you see microglial cells shifting back into that homeostatic state? Because all of the symptoms that you've just described, from mood to sleep to cognition, all of them are regulated through those immune cells, and magnesium could be one of those triggers.
Right. And we know that, I know I've seen it in practice. If I test someone's inflammatory markers and they're high, and I dose them in a pretty higher end dose of magnesium, I can get those inflammatory markers down. And those are usually driven by like IL-6 or TNF alpha, right? And so we know that those molecules are being affected by that magnesium. So threonate, we know it actually decreases that neuroinflammation. So yeah, I think that it's probably targeting, and because the L-threonate, we have to remember, it's the only form that can kind of cross the blood-brain barrier, and that we can see it increases magnesium levels. And we know that magnesium does have that neuroprotective factor and that neuroinflammatory response, and it improves upon that. And so I think that it's why we're starting to see it starting to go towards like the mood disorders, and they're even looking at it for migraine prevention now, because again, it's the vascular component in the brain. And this is something that this form of magnesium is really special at. And so it's also one of the most expensive forms of magnesium. So, and again, this would be a form I would only want to take on its own to get the best possible outcome. I wouldn't probably want to take it in a formula or in a, 3 or 4 different forms of magnesium, because you kind of want it to do exactly what it's meant to do. And that's to get into the brain and take care of that neuroinflammation and calm down some of those excitatory receptors.
Yeah. And you could imagine that if you're taking a blend, they're not going to blend in at a high level the thing that's the most expensive form. They're going to blend in something that's cheaper. I think it'd be very interesting to see, because all of the different symptoms, again, there's an incredible parallel between this and vagus nerve stimulation. I'm wondering, many of the benefits of vagus nerve stimulation are attributed to the release of acetylcholine. And that when you stimulate in the central nervous system, the vagus nerve, the afferent fibers go up into the brainstem and cause the release of acetylcholine from the nucleus bacillus. I'm wondering whether or not either the synthesis of acetylcholine or the effectiveness of acetylcholine or the binding of acetylcholine to receptors is affected by magnesium. Does magnesium play a role in? I'm trying to figure out where the two things meet, because I suspect that taking magnesium supplements would probably enhance the value of vagus nerve stimulation, and that vagus nerve stimulation may be in some cases dependent upon magnesium levels being high enough. And I'm trying to figure out how that may work.
Yeah. So if we look at how it improves vagal tone, it's by calming down that nervous system and then supporting the neurotransmitter balance. That's kind of what the research is showing us. And when we can do that, magnesium actually improves vagal tone. And so it's this whole overactivation or overstimulation of the sympathetic nervous system that magnesium is so good at regulating or bringing down. And when it reduces cortisol, when it supports that parasympathetic activity, that's, I think, where it's actually starting to improve heart rate variability, vagal tone, even that gut-brain axis. There's that support with the vagus nerve, and we know that magnesium is going to help regulate that gut motility and support the microbiome, which is going to influence the vagal signaling that's going to happen. And then, of course, the neuroinflammation is a big piece. And I think, with magnesium helping to bring that down, we can reduce that oxidative damage and then support the neural health over time. But those are the actual pathways that they have lots of research on, and that they're very confident in kind of expressing and telling and kind of using in different scenarios. And so I think if we had to look at it from an overall perspective, it's what magnesium does to the actual nervous system itself.
It's sounding to me like magnesium has this amazing capacity to handle many of those root causes at their oxidative stress side, at that incitement of inflammation step.
Yeah.
Not quite once the inflammation is chronic. Yes, when we supplement, it's going to help support it, but it's almost pre-immune system, if you kind of catch my drift, right? The immune system is going to react initially, but if there isn't as much inflammatory burden, root cause based biochemical stressor to react against, then the immune system doesn't need to be turned on to the inflammatory state as readily. And so we're almost able to maintain that M2 state macrophage when we have sufficient levels of magnesium present, because what it's doing is it's buffering, or it's essentially lowering the inflammatory burden, that initial step to push the accelerator in the immune system. It's almost this pre-step, and that's how I visualize it. And so what we then see when we do have enough magnesium is vagus nerve tone goes up, because we don't have as much inflammatory burden to handle in the first place, right? There's less pressure on the accelerator, and the brakes then can work better because they don't need to be worked on as much. And so that's kind of how I visualize it. Does that compute for you there?
Yeah, so you've said it perfectly. It reduces those pro-inflammatory molecules, and then in that way, magnesium keeps the immune responses from getting overexcited or overstimulated. And that's going to obviously help prevent any chronic inflammation from getting worse, and tissue damage, which is that oxidative stress. Yeah.
I love it. It sounds like there's such a synergistic effect between adding in this depleted molecule that is very obviously depleted in so many chronic health conditions, and understanding that when vagus nerve is functional and given the opportunity to function, we can regulate the inflammation at an even greater level. The synergistic effect between having a good amount of magnesium in and ensuring that vagus nerve function is optimized together will then work to control that chronic inflammatory burden.
Yes, like I think of it in your car analogy. One's the brake pads, so your brakes will work, and one's gasoline in the engine, so that your accelerator is going to have an effect. You need to have both there. But coming back to something else that you said a while ago, you talked about things that tend to deplete or compete with magnesium levels. You talked about sugar depleting magnesium levels tremendously. And we could probably spend a day talking about the effects on insulin and insulin signaling and insulin growth factors and nutrient sensing, et cetera. And maybe we can get to that too. But I was really fixated on the idea of fluoride competing with magnesium. And one of the things down here in the States that's become, a cause celeb recently, and it's not new by any stretch, but I guess there's more evidence coming out now. Even the FDA or CDC or somebody mentioned that fluoride in drinking water has an effect on cognitive development, and that they attribute a portion of or lower IQs to fluoride in the water. And I'm wondering whether or not, if fluoride is competing with magnesium, and as a result of that, you're seeing a cognitive decline in neurodevelopmental issues, whether or not magnesium supplementation across the board, or maybe magnesium threonate in children during development, is something that can sort of protect them against the fluoride. The fluoride's going to compete, but if there's a higher level of magnesium, then at least it won't compete as effectively. Is that something that we should be fortifying food with? Is it something that we should be putting into our children's, not that we want to start our kids eating pills right away, but are there things that we should be promoting that our children eat so that they have that level of magnesium to protect them against any fluoride exposure?
Yeah, so exactly. And so fluoride is definitely going to compete. And when I say compete, I think I should probably just define that. So when fluoride is present, it's going to bind to the magnesium in the gut, and it kind of forms what's called magnesium fluoride, but it becomes an insoluble compound. So then you can't, it's not really doing, it reduces the bioavailability of your magnesium. And this is where the competition comes in. And so fluoride kind of wins and magnesium is depleted. needed. And of course, it's going to prevent absorption in the bloodstream. So that's kind of what the fluoride and magnesium component is.
So it sounds like what you want to do then is get a magnesium supplement or exposure to magnesium that doesn't rely on the digestive tract. So things like magnesium oils and sprays and creams and things like that that are, or even just Epsom salts getting through the skin, that would get in and not necessarily end up, I mean, yes, there's still going to be fluoride elsewhere in the body.
In the drinking water and the bath water with the Epsom salts too, right? So because there's fluoride in the water, we have this competition. Obviously, the level is not going to be the same, that it's a 1-to-1 match between magnesium and fluoride. But if the levels are decreased, then the absorption rate is going to be lower. So I would almost ask the question, is it more of a gut microbiome type issue and a leaky gut type of issue that's being triggered by fluoride? And are there any particular kind of gut findings that you've noted with regards to the absorbability of magnesium?
Yeah, so there are, well, this is going to also be unique to people who have, let's say, inflammatory bowel disease, right? So they have a lot of trouble absorbing their nutrients. And so they're not going to absorb many of what you actually give them as far as supplements. But magnesium bisglycinate or glycinate, same thing. It's a special form of magnesium that actually, because it has that amino acid transport mechanism, it bypasses the need for stomach acid to break it down. So it is going to be much more absorbable for people who have those deficiencies and can't absorb nutrients. But it's also the form that we use if we're seeing a lot of fluoride exposure. And it's one of the forms that can help to kind of get that magnesium and get it absorbed. But we also do, if we see a big deficiency, we just try to, get some filters for our bath waters, or just kind of filter out, like here in Ontario, we have lots of different water filters that can filter out some of that fluoride exposure. And, we have to kind of work from other ways, because sometimes if that magnesium is binding and it's kind of making it into this insoluble compound, then we're not going to get the absorption that we want. And if you're using fluoride toothpaste and you're washing in fluoride water and, all the other things, and you're drinking fluorinated water, then you have a lot of fluoride exposure, and it's obviously going to compromise your magnesium levels.
So it sounds to me like maybe the recent reports about fluoride in the drinking water affecting children's IQs, it may be because of this magnesium deficiency that it's inducing. And that may be the mechanism. I mean, I'm trying to. I mean, I know that there have been people who've been opposed to fluoride in the water for a generation or two, but those complaints are usually associated with some observation of some very observant person or people who are seeing some effect that they know is wrong, they know is off, but they don't have a scientific explanation for why it's doing what it's doing. Have we just now in this conversation maybe made a link here and said that magnesium deficiency is being induced by fluoride in the water? And we talked about the cognitive importance of magnesium in cognitive development and cognitive function. Is that what the issue is? Is that the pathway that needs to be investigated? Maybe it's not known yet. I mean, as you said, there's a tremendous amount of work being done right now, but maybe this is something that we need to be looking at.
Yeah, I mean, it's definitely for future research. I don't think the research is there yet to make that link. And we also know that not all of the magnesium, so especially something like bisglycinate, isn't probably going to get into the brain quite as easily as something like threonate would. So there's going to be that whole link too. So I'm not sure if we can make that assumption at this point, but there might definitely be some form of correlation that could kind of connect those two. But I do think we need a lot more research in that. But we do know that we know for certain that, if we minimize fluoride exposure, we see increased magnesium levels. That we know. Yeah.
I would almost even say that like fluoride toothpaste used by children may actually be driving this at a higher concentration than just the fluoride in the water. Yes, fluoride in the water is going to contribute, but we know, and I have 2 young kids, like they swallow toothpaste pretty effectively. And that means that there's a higher dose of fluoride that could be making its way in. So I use non-fluoridated toothpaste with my children. And that's been, I think, pretty effective because they're pretty smart and they drive me nuts. They're
doing their job.
They are absolutely. I'd love to kind of talk a little bit about food because I think we've talked about supplementation. There's a few different forms. And you mentioned kind of that gut-brain axis, that leaky gut piece. What are some of the best foods that we can ideally have for ourselves, for our kids, to ensure that they are getting enough magnesium in through their dietary sources so that we don't always have to supplement?
Yeah. So there's not a lot. So this is another problem, right? So most of the magnesium rich foods are plant foods, for one. Salmon is kind of the outside source where it's a protein and it has a little bit more magnesium than any of the other animal-based proteins. But your leafy greens are rich in magnesium. Avocados are rich in magnesium. Bananas, not just potassium, they have magnesium. But I think your biggest bang for your buck is going to be pumpkin seeds. They're kind of the most magnesium-rich foods that we can have. You'd have to eat like 3/4 of a cup, but you would get pretty close to your RDA if you did that. But there's not a lot of foods like dark chocolate, again, but it's got to be 80% cacao or higher in order to get that. And then we have some lead stuff to worry about. So
and you got sugar also.
Yeah.
You got sugar also.
Right. Because like it's not obviously, unless it's 100%, there's going to be some form of glucose coming in. So, but yeah, like mostly your plant foods, your leafy greens, your legumes, if you can handle legumes, will also be higher. Tofu is high in magnesium. What else? We've got your flax seeds, chia seeds, almonds. Those are really high in magnesium. And that's pretty much it. There's like, the list is short. It's not terribly long. And then you have to eat all that. And bone broth, there's not a whole ton of magnesium in that. No.
That's interesting because bone does obviously contain one of the highest sources of magnesium in the body. That would be a tough one to, ideally it would be a great one, but it doesn't seem to fit that bill.
Yeah, it's really, unfortunately, I mean, a lot of people ask me, can we get enough magnesium from food alone? This is like a common question. And when we see how much lifestyle factor stuff depletes magnesium, it's really hard to get in enough magnesium through food every day because we need to be getting to that at least 420 milligrams to meet like deficiency, right? So just so that it's sufficient for the average individual. And you need to be eating this every day. And then you can't have anything depleting your magnesium at the same time. So you can't have stress. You can't be insulin resistant. You can't take any of the medications, which 1 out of every 5 individuals is on one of those medications. They are the most common prescribed medications. So it's unrealistic. I think if you are a very healthy person, you have nothing wrong with you, and there's nothing going on, you might be able to have a diet that substantiates enough magnesium for you. But I think if you want any of the benefits, you most likely have to do some form of supplementation, whether it's transdermal or swallowing a capsule or doing powder or liquids or whatever it is that you wish to do to at least get enough magnesium in the system to let it do what it needs to do.
I'm going to put a big plug out there for pumpkin seeds. I happen to love pumpkin seeds. I actually have bags and bags of them. They sell them at Costco. They're easy. They're really good to put on salads. So if you said pumpkin seeds are like the number one, I'm sitting here cheering. That's one of my favorite little snack foods to go to.
Yeah. They will give you the biggest result of all these. You're not eating a lot of calories to get to the value. Whereas in leafy greens, you got to eat like 4 or 5 cups. Like it's unrealistic for most people. Yeah.
How about pistachios and macadamia nuts? Are they good too? No.
No.
They go well together with pumpkin seeds.
Almonds are good. And again, if you have to eat the amount of volume of almonds, it sometimes negates the benefit, right? Like they're not always, we can't eat bags of nuts every single day. And this is every single day. Like this isn't once a week or, this is a daily.
Kidney stones. Yeah. People who make kidney stones, you got to worry about almonds and some of the nuts that have high oxalate levels. So
Right.
It can be a little careful there.
A lot of
It's
your leafy
interesting.
greens, right? Yeah.
Mhm.
Yeah. But we also know that kidney stones are a breakdown. Like we know that kidney stones are also, you don't have enough magnesium in the system to break down that excess calcium, right? That's magnesium's job. So a lot of calcium, excess calcium related conditions is a magnesium deficiency.
Very interesting. This has been an awesome conversation. We recently had on Dr. Anthony Chafee, carnivore MD. And one of the questions that we didn't really get the chance to ask, it was a very long conversation, but it was a really unique one. He had this constant kind of point that plants are trying to kill us is kind of the underlying theme of the carnivore diet. That said, we don't really have tons of magnesium present in animal foods. And that's obviously a missing piece. I wonder if maybe the carnivore diet in its form is maybe more of an elimination style diet, which is very beneficial to eliminating many of the sources of stress to the gut, to the microbiome, to those challenges. And as we can see, plant foods are necessary to provide these magnesium pieces. But I wonder if it is our day-to-day lifestyle and our habits and our challenges and stressors that we're experiencing in all forms, biochemical stress, emotional, psychological, physical stress, all of these things that are working to deplete that magnesium. And it's making it more difficult for us to absorb what's there. I want to ask one last question on the food piece, because has this changed over time? Is there depletion of magnesium in the soil, and that's why we're less able to grab it from food? Is that something that's happened over the last probably 50, 100 years?
Absolutely. Yeah. So farming practices have changed. Obviously, our lands are not as rich in nutrients, and it's not just magnesium; it's in all of our minerals and vitamins. So yeah, I mean, they've compared, spinach from 25 years ago to today, and it's like not even a third of what the nutritional value was back then. So yeah, this is what I was saying with, like, you have to eat 4 to 5 cups of leafy greens just to get, and this is not even like RDA value, it's like 150 milligrams of magnesium. Like, it's a lot more food to get to what we actually were getting to even 10, 15 years ago. So definitely farming practices have changed, and that has changed our nutrition that we're getting from food. So definitely it plays a role. Absolutely. There's no doubt. And it's another reason why I just don't think we can rely on food alone to get what we need for our magnesium stores. I just don't think it's possible.
Particularly based on our current lifestyle factors and the amount of stress that we're under, right? It really doesn't compute. So that makes a lot of sense. JP, any final questions on your side there?
No, I got a homework set of things I got to think about, and some projects that we might want to recruit people to work on. So real interesting stuff.
Love it. Dr. Barb, this was a wonderful conversation. Where can people learn more about magnesium if they're really interested in the topic? I know you got the book, and where can they go for any resources that you are sharing with them?
Yeah, absolutely. So definitely there's the book, Magnesium, the Missing Mineral. It's available on Amazon. It kind of goes through everything we talked about today, and we kind of split it up into all the major organ functions. So there's a chapter on pretty much everything and how magnesium plays a role. And you can also find me on Instagram at Dr. Barb Woerger. There, I pretty much put all my magnesium information in a nice, easy to digest way, because I know it can get complicated and people don't always understand all the pathways. So I try to make it easy to understand so that people are grasping onto the concepts. And that's probably where I'm most active with most of my information on magnesium. So definitely head there and check out all the resources there.
For sure.
Wonderful. Well, this has been just enlightening and wonderful, and always great to see you again, Barb. Thank you for sharing all of your wonderful insights. And for anybody who got to this point in the podcast, please share this information with one person who you think could really benefit from hearing this information to help improve and upgrade their health. Thanks for listening, and we will catch you all on the next one.